Now let's look at this problem. In this one, it's giving us the value for tangent, and it's asking us to go back and find the angle. Because of the way they list this interval, this tells us that they want the angle in radians. And also because this is going from 0 to pi over 2, that's only the first quadrant. Because tangent is sine over cosine, I'm just going to go back and look at some of the special angles in the first quadrant and figure out which one, if I took the sine value over the cosine value, would give me the square root of 3. I'm just going to look at 3 of those special angles because I know it's not 0 or pi over 2. For those ones, the tangent is either 0 or it's undefined. I'm just looking at these 3, pi over 6, pi over 4, and pi over 3. So I'm looking at the sine value and the cosine value. For pi over 6, the sine is 1/2 and the cosine is the square root of 3 over 2. For pi over 4, they're both the square root of 2 over 2. And for pi over 3, it's these two switched. So now I want to think about which one of these, if I take the sine and divide by the cosine, is going to give me the square root of 3. And that's going to be this one. If I take the square root of 3 over 2 and divide it by 1/2, the 2's cancel and I just end up with the square root of 3. So that means the angle that would give me this for a tangent value would be pi over 3. Here's another one that's similar, only this time our angle is in the second quadrant because the second quadrant goes from pi over 2 to pi. This is a second quadrant angle, and again the angle measure is supposed to be in radians. So let's go first and find the reference angle that would be in the first quadrant, and then we'll work on finding the second quadrant angle that goes with it. For our reference angle, I'm going to call this S prime. The cosine would be, instead of the negative square root of 2 over 2, it would be the positive square root of 2 over 2. If we think about our special angles in the first quadrant, the one that has this for a cosine value is pi over 4. Because we're looking for this in radians, we can just think about what other angles are in this family. So we've got the pi over 4 family, and really all we have to do is go around, if we go from 0 to 2 pi and pick out all the ones of these that don't reduce, that'll give us our entire pi over 4 family. So pi over 4 is in the first quadrant. If we go up to the next one that doesn't reduce, that would be 3 pi over 4. That's in the second quadrant. The next one that wouldn't reduce as a fraction would be 5 pi over 4. That's in the third quadrant. And the last one we would get to that wouldn't reduce before we get to 2 pi would be 7 pi over 4. That's in the fourth quadrant. We were looking for one in the second quadrant. That would be 3 pi over 4. And if we think about it, if we know that's in the second quadrant, that means the cosine will be negative, so it fits what we had up here. So our S is 3 pi over 4. Here's another similar problem. We're looking for an angle measure in radians. This would be in the first quadrant. Only this time we have a decimal value for our cosecant, and it asks us to round our answer to 2 decimal places. This one we're going to use our calculator, but also this is cosecant instead of sine, so we're going to have to use the reciprocal before we can use our inverse trig function. Sine is 1 over cosecant. That means the sine of S would be 1 over 3.6185. And if we want to get back to the angle, if we want to cancel out the sine function here, then we need to use the inverse sine function on both sides of this equation. This is what we're going to do in our calculator. And for these problems, especially when we're dealing with both degrees and radians, probably before every question you want to check and see which mode your calculator is in, just to make sure it's in the correct one. For this one, we want our answer in radians, so we want to make sure we're in radian mode on our calculator. Now I can use my inverse sine function. That's giving me my angle measure in radians, and it asks me to round to 2 decimal places. That gives me an answer for S as 0.28 radians. In this one, we've got a point which is on the unit circle, and we've got the coordinates of the point. The only thing about this being on the unit circle is that we know the radius is 1. So if we were using x, y, and r, that would automatically tell us that the r is 1. We could use either the x, y, and r idea. Our x would be 7 over 25, our y would be negative 24 over 25, and our r would be 1. Or we could just go directly to the cosine and the sine values because we know this is on the unit circle. So automatically, cosine of theta is 7 over 25. Sine of theta is negative 24 over 25. We could use these two values and some of our identities to find the other 4 trig function values. For example, from this we could get the reciprocal, which is secant of theta, just by flipping this over. That would be 25 over 7. We could use the reciprocal of sine, which is cosecant of theta. Flip this over and that would give us negative 25 over 24. And then to get tangent, we could use our quotient identity, which is that tangent is sine over cosine. That would give us negative 24 over 25 divided by 7 over 25. The 25's cancel and we would end up with negative 24 over 7. And then the cotangent of theta is the reciprocal of this, which would be negative 7 over 24.